So our books are out and open to page 200, and we're going to be writing in our composition books, what are fossils? Yes?
If you found a really rare fossil, could you sell it for like a lot of money?
Good question. I guess it depends on what the market for that was. So if you had a museum that had money that they could buy something like that, it's possible, but probably not probable. So fossils come in different types of fossils. And the one that we're going to talk about first is very, very rare, and it's a woolly mammoth. And so woolly mammoth disappeared from Earth about 10,000 years ago. But there was actually an instance where they found the remains of a woolly mammoth that was partially frozen in a block of ice. And the reason why the fact that this is so rare and that it was partially frozen is that people were able to actually look at the soft tissue. And so they were able to look at things like hair and soft tissue, which normally dinosaurs they can't. They usually just find the bones because of the types of fossils that they are. So that's what we're going to talk about here on page 200. Yes?
What is soft tissue?
Soft tissue is like, think about your skin, your hair, your anything that would be like an organs and things, like your skin and your hair and your organs. Your hair is dead, your fingernails are dead, but your soft tissue is like your skin, and so fossils, usually when you find them, are the bones, or they're the trace of bones, like a footprint. So because they've gone through what we call decomposition, and they've gone through the process where they've broken down and had other animals eat them, and decomposers have eaten away at their skin, and we just have the bones. But on a few rare occasions, they've actually had animals that had frozen remains. So yes?
If it's frozen, can it be alive? Not being like melted?
It can't be, no. So imagine this being, it's not just frozen, but it's been frozen for 10,000 years. So there's no opportunity for it to be alive again. And even living things that freeze don't stay alive. People can't freeze and then come back to life. Animals don't get frozen and come back to life.
God can.
I'm sorry?
God can.
Well, that's the religion class, that's not part of our science class. Yes?
This is kind of weird, but like whenever I go to my aunt's house and like I see Bubble, we take the dogs on a walk like every morning, and like there's like a sidewalk that has like one paw print on there.
Yeah, so
like,
maybe a dog stepped his paw in it, or someone made his paw print. Yep, and so that.
No, it was like a fossil of it, maybe.
Oh,
Like,
okay. Huh. Yes.
So it was already dead?
I'm sorry?
The mammoth was already dead?
Yes. Well, we don't know that for sure. So that's what we're going to read on page 200. So it says woolly mammoths disappeared from Earth about 10,000 years ago. Can you get your book out, honey? Thank you. Page 200. Scientists have learned about mammoths by studying their bones and other remains. But in 2007, however, scientists got an amazing opportunity to learn about what mammoths were like. That year, reindeer herders in northern Russia discovered the frozen body of a baby mammoth. The mammoth had been frozen underground for about 40,000 years. Except for missing toenails and hair, the month-old mammoth was in nearly perfect condition. Even the food and its stomach was preserved. What do you think scientists might learn from studying this baby mammoth? What do you think they may have learned? What do you think? Well, if we know it was in his stomach, what do we know? We know what it, yes.
What it eats?
We know what it eats. Sure, we know what it ate back 40,000 years ago. What else might they know? Yes.
What it looks like?
What it looks like. It said that with the exception of some missing toenails and hair, it was pretty well preserved. Yes.
So is it a mammal?
It's a mammal. Yep, it's a mammal. So the discovery of this animal, such as the baby woolly mammoth, is very rare. For this type of preservation to occur, the animal remains completely frozen from the time it dies until the time it was discovered. So it never thawed out in any time. The cold temperatures prevented the decay of the soft parts of the animal. That's when they said soft tissue. And the ice also protects the animal remains by eating from being eaten by other organisms. As a result, fossils were preserved in this way to provide scientists with more information about the past than other fossils can. In the case of the baby woolly mammoth, scientists were able to study even its internal organs because they were still intact, because they were frozen solid. So think about how many people have ever seen an animal carcass or like a bug or a lizard that was eaten by ants? Has anybody ever seen like the skeleton of a lizard that was eaten by ants?
Yes.
And so there's lots of things in ecosystems that their job is to clean up things. So when an animal dies, their job is to clean up, and that's like the decomposers. And so because they decompose and they do their job so well, that it's very rare to find an animal that has soft tissue still intact, unless, like this woolly mammoth that was frozen. Yes?
So you say ants eat humans when they die?
Yes,
Yes, of course.
absolutely.
Yes, ants are gonna eat us.
Other ants, well, animals can. Well, it depends on most people would be buried in a coffin, so if they were buried in a coffin, you probably wouldn't be eaten by ants. But yes, other animals or decomposers, bacteria and things would devour. But when you die, your body goes to earth, but your soul goes to heaven, so you don't need to worry about that because you wouldn't know. It's just a body. Yes.
Once I was at the beach and I found this like whole fossil of a fish that was like this big.
Wow, very cool. All right, let's take a look on page 201, please. So at the top of the page, there's two different tracks. I want you to look it up the page of 200 and 201. So the first one, it says, compare the tracks and tell what you can conclude about the animals that made them. What do you think about the first animal, the first picture? What can you tell about it, Audrey?
It's this footprint is bigger than the one in this picture.
Okay, say it one more time.
The first footprint is bigger than the one in this picture.
Okay, the first footprint's bigger than the second one. What else can you tell? Yes.
The first one is like not on sand and the other one is
Okay, so you can see that one is on sand and the other one's probably in what?
like red rock.
It's some kind of rock, right? It's some kind of red rock. Gio?
I just have a question.
Yes.
How would if you see this woolly mammoth?
Mhm.
Look at its feet and then look at the footprints.
Those aren't the same animal, honey. They're not trying to show you the same animal. They're not any animal, the footprints on the page have nothing to do with the woolly mammoth. Yes. They both look alike. Okay, what do you think, Lily?
They both have 3 toes or parts, whatever.
Okay, they have 3 toes or 3 parts of their hands. Very good. That's good. Okay, so what you can tell about these individual pieces is that we know that they're in different substances. We know that they're different sizes. And I can tell from the one that's darker on page 200 that it was probably something that happened a very long time ago, that it's old, right? Where the other footprints are kind of fresh. They're fresh.
Yeah,
So there's different types of fossil clues that we can have. Let's take a look on page 201. Some plants and animals that lived millions of years ago have left clues about their lives. The line of footprints preserved in rock can show how an animal walked. The skeleton of a small animal can help scientists understand what the animal looked like. Skeletons and footprints are examples of fossils. A fossil is the remains or mark of an animal or plant that lived long ago. So if you have your highlighters, we're going to definitely highlight that sentence. Find where it says the word fossil. A fossil is the remains or mark of an animal or plant that lived long ago. Scientists can study fossils to learn about species that are extinct. An extinct species no longer exists. So we're going to highlight the word extinct also. Extinct species no longer exists. More than 1 million species currently live on Earth, but many more have become extinct. In fact, most types of organisms that have lived on Earth no longer exist today. So most things that were alive are no longer alive. So do you see the picture on the bottom of the page? Does anyone want to guess what that is? It says in the caption. Tatum?
It's looks like an alligator head.
It kind of does, doesn't it? It's actually something that lives in the ocean. It's called a trilobite. Trilobites are now extinct. They had hard shells and they lived in the sea hundreds and millions of years ago. So those are something that you could still find a fossil of today. Turn in your books to page 202, please. So they use the word sediment, and sediments are small pieces of rock, sand, shell, or other materials. So sediment is anything that's left over. It could be like, if you think about when you walk in your yard, how many people ever get dirt stuck in the bottom of their feet? Like your feet?
Yes.
So that's the kind of like stuff that's gonna be fine enough and small enough that would be sediment. So how fossils form? Fossils form in different ways. Most fossils form when a plant or an animal dies and becomes buried under layers of sediments. Sediments are bits of rock and shell, sand, and other material. Over time, the sediments hardened into rock and preserved the shape of the buried plant or animal. The diagram below shows the process. So do you see what it looks like on the bottom?
Yeah.
So it started out as a dinosaur. So the animal dies and sinks to the bottom of the lake or shallow sea. The blank parts of the body decay. What parts of the body are going to decay first? What are we going to write in there where the pencil is? What could you write in there where the pencil is? What begins to decay first? Lily?
Soft.
The soft parts of the animal decay. Write that down. Soft. On page 202, where the pencil is, on the bottom of page 202, it says an animal dies and sinks to the bottom of a lake or shallow sea. The soft parts of the body decay. Go ahead and write that down. Do you see where the pencil is? Does everybody see that? All right, write that word down. So we're going to write the next word. Look over at the next box there. It says sand, mud, and other sediments settle on top of the animal's remains. So sediments are those things like sand, mud, dust, rocks. Any of those things are called sediments. They're bits of rock, sand, or shell, or other material. And so they settle on top. So they stay there and they become smushed and hard for a very long time. And once they become hard for a very long time, they become more layers of sediments form. The sediments harden into what? Once sediment turns into rock, turns into rock, preserving the shape of the animal's parts. So you can see in the picture there that you can still see what the dinosaur's skeleton looked like. Are there any soft materials still on it? Any soft tissue or anything? No, there's none of that anymore because it's already gone through the decaying process. And the last picture says, over time the rock layers above the fossil wear away and the fossil appears near the Earth's surface. So if you were an archaeologist or a paleontologist, which is a scientist that studies dinosaurs, you would be on an archaeological dig and you might see a little tiny piece of a dinosaur, a little tiny piece of something you think is a dinosaur. They would then quarantine the area and quarter it off so only certain people can go in. And they would go in with very small tools, very small knives and a little chisel, little hammers, and very, very carefully unearth a little piece at a time. So that's what they would be able to expose the whole skeleton. They don't just want one bone, they want to expose the whole skeleton. Yes?
A lot of animals are going to be extinct by 2050.
I've heard that. Yeah, that is not good. We don't want animals to be extinct.
What?
We definitely don't want
What
animals
is
to
a
be
sea
extinct.
turtle?
All right, let's take a look on page
Rhino.
202. 202, how fossils form. So we went through the first paragraph. Let's move on to the second paragraph where it says usually. Usually only the hard parts of the animals, such as the bones and shells, become fossils. The soft parts decay or may be eaten by other animals. Once the remains of an animal are buried, different things can happen. Sometimes the buried remains break down and disappear, leaving an empty space in the sedimentary rock. A space in the rock in the shape of a living thing is called a mold fossil. Later, minerals from the surrounding rock might fill the mold fossil, and over time, these minerals harden in the shape of the mold. This type of fossil is called a cast fossil. Dinosaur bones that come from the cast fossils are not bones at all. They are usually hardened materials. And so the hardened materials that other materials kind of go in their space. So do you see the pictures on page 203? Those are called ammonite fossils. And so you can see one that looks like the actual fossil, and then you look at the other two and they look like the fossil was pressed inside. So what happened was it pressed into sedimentary rock. It got other sediment was on top of it, and it kind of smushed it there for a very long time, and that made a cast of what was once there. Does that make sense? All right, turn in your books to the next page. Yes?
So it's some of these shells, there's actually like this squid-like creature that goes inside.
Yes. Yes, it was, if you look at those pictures there, you could see that there was another kind of an animal in ammonite that went inside it. Yes?
I can have a tissue.
Yes. All right, so how many people have seen the movie Jurassic Park?
Yes.
Anybody see Jurassic Park?
Yeah.
So at the beginning of the movie Jurassic Park, there is the grandfather that owns the park, that starts the park. And he has a cane that has a piece of amber. And amber is sap from a tree that has hardened, and he had a mosquito in it. And so the mosquito supposedly had sucked the blood of a dinosaur, and then it was hardened inside that piece of amber. That actually happens very often. They will find bugs hardened in tree sap quite often. And so that part of the story is actually real. Like, that happens all the time. So here's the picture at the top of the page. This fly has been preserved in amber. So it's kind of hard to see. It looks like there's just a yellow part, but imagine that being an amber stone there. Did you have a question? No. Okay. So other types of fossils. Casts and molds are called body fossils because they are formed from the body parts of living things. There are several other types of body fossils, and sometimes the whole body of an animal can be preserved in a fossil. For example, insects can become trapped in sticky tree sap. The sap surrounds the insect and hardens over time. The hardened sap is called amber. Amber preserves all of an insect's remains, both the hard parts and the soft parts. Parts of the animal's body, such as teeth or bones, make up another type of body fossil. The bones of some animals were preserved in tar pits. Tar pits are oily pools that exist on Earth's surfaces. Animals that fell into the tar pits become trapped. The soft parts of the bodies broke down, but their bones remained. Fossils of these animals are actual bones and not hardened materials. So there's different times where we have actual animal relics, like the picture here. Does everybody see the picture on the left in green? That is the skull of a saber-toothed cat, and it was preserved in a tar pit. So it's actually the bones. It's not a mold fossil or a cast fossil. It's the actual remains. Yes?
The last word on like the paragraph on one type of fossil is minerals, not
Fossils of animals of bone are not hardened minerals. Did I say hardened
you said
materials?
materials.
Materials. Yes.
And I'm sure second grade when I was in high school, we went to like a little aquarium, and it had bones of a megalodon, but
Yeah.
I'm sure they're fake.
I actually have a megalodon tooth that I'll share with you. I have to remember where I put it because I got it last year at somebody that was selling them at a craft show because I knew we'd studied that in class, so I went and got one, and it's quite larger than any type of shark's tooth that you would find. It's pretty neat to see.
How big
Pretty
is
good
it?
size.
Like this big?
It's probably about that big. Yeah, it's pretty good size.
That's a big.
It's good size. So trace fossils. Most fossils show what the parts of a plant or animal look like. Trace fossils give clues about a living thing's activities. Footprints or tracks are a kind of trace fossil. Preserved burrows, nests, and eggshells are also trace fossils. Studying trace fossils can help scientists answer questions about where an animal lived and what it ate and how fast it moved. How can they tell how fast an animal moved by looking at its footprints? How can they tell how fast it moved? What do you think? Aiden?
Probably because of its toes and how its foot looks like.
Okay, so you can tell by its toes or what its foot looked like. What else? Yes.
How big his steps are.
How big their steps are. You can see how big their stride was, like how far apart their legs walk. So that would be one way. Yes.
How many they took at once?
How many they took at once? Sure. Yes.
Like how like how many of them
Okay.
in space?
All right. So you could see how maybe how fast they moved. If you could look how many they are, that's a good observation. Yes.
How long the legs are?
How long their legs are. We can kind of guess how long their legs are. Did anybody think about the depth of the trace itself? Like think about when you walk on the beach. And so if you're heavy, right, if it's your mom or dad and they're walking and they're heavier than you are, their footprints are going to be a little deeper, right?
Yeah.
If you run, are your footprints deeper or shallower?
Shallower.
Usually shallower because you're trying to run really fast. So if you look back at that first picture of the footprints of what I think is a bird in the sand, we know that it didn't stand very long in one place and that it probably moved pretty quickly. So you can definitely make some observations, some scientific observations based on how the animal moved based on our trace fossils. Okay, I'm gonna go ahead and stop there for now. We're gonna go ahead and share a quick video from BrainPop.